Rules for arranging a subset of things. In this presentation, you will learn how to arrange a subset of things where repetitions are allowed or not allowed. We recall the fundamental counting principle, which states that if there are m ways to do one thing and n ways to do the other thing, then there are m times n ways to do both things. Let us look at the rule for arranging a subset of things. Repetitions are not allowed. It simply states that number of arrangements of n different things taken r at a time is given by, right? P, n choose r is equals to n factorial over n minus r factorial, right? So in this case, you would see that we are saying repetitions are not allowed. The R is representing the subset that we are talking about. Let us look at this example so that we understand better what the rule says. But in solving these problems, I'm not directly going to apply the rule. I'm going to use another approach so that we come to verify the rule itself. So in A, it said that in how many ways can 4 vacant places be filled by 7 different people? That is the question we are supposed to answer. In number B, how many 5-letter words can be formed using the letters of alphabet? We know that letters of alphabet, there are 26, but we want to check how many 5-letter words we can form from the 26 letters of the alphabet. This is why what is important is know that this is a subset. 4 vacant places is a subset because it is going to be filled by 7 different people, right? A solution in A, 7 different people can occupy 4 vacant places as follows, right? I've come up with 4 columns to represent the 4 vacant places. That is, this is vacant place number 1, 2, 3, 4. But then when we put 7 here, the fact that we have 7 different people, we are saying vacant place number 1, the 7 have got a chance of occupying there, right? Once this is occupied, then we are left with the 6. Then the second vacant post, 6 people can occupy. Any one of them can occupy there, right? Now 1 and 2 are filled. Then we are left with what? With 5. That is 5 people. Any one of the 5 can fill vacant post number 3, right? Once we have filled this, then we are left with how many? 4. That means the 4th vacant place, any 4 of the 7 people can fill this post. Knowing as we do, we are saying 4. That means 1, 2, 3 already have occupied here. 3 plus 4, we still have 7. But the understanding is when it comes to a position, any of the people have a chance of taking position number 1. Once it's filled, we have 6 left. Once it's filled, we have 5 left. Once it's filled, we have 4 left. That's the understanding. Now, using the fundamental counting principle, where we are saying filling this position, we can do that in 7 ways. Position 2 can do that in 6 ways. Position 3, 5 ways. Position 4, 4 ways. But how many together? Or what we need to multiply 7 times 6 times 5 times 4. But then I'm going to transform this because where I want to arrive, I want to show you this portion. That means we are saying that 7 times 6 times 5 times 4. I can continue on to say times 3 times 2 times 1. But because this is not the red one, is not part of it, I divide with the same thing. So this is why I'm saying this is still equal to that, so that this can cancel out and remain with that. But at the top, now it is 7 factorial. At the bottom is 3 factorial. But then I go on to check now the 3 factorial can be written as 7 minus 3, 7 minus 4, I get 3, which is now the same as 3 factorial. So I've come 7 factorial at the top, bottom 7 minus 4 factorial, right? And this, now we have arrived at our formula. Check, right? We have 7 people, that is n. Then 7 minus, we want to fill 4 vacancies, minus 4, right? Which is what we have here. This is the same as this, right? So at the end, we are simply saying, if we had used this approach, now using directly the rule, we are simply saying you take the 7 different people over 7 minus the subset you are going to have of the 7, which is 4, then it gives you the same answer. So I'm simply saying 7 from 7 pick 4 is the same as 7 factorial over 7 minus 4 factorial, which is what you have seen here, starting from the understanding that when we want to fill 4 vacant posts, these are the posts, then we have 7 people. This is how we can place them. So in essence, this is what it means to use the rule. Now let us go to B. We are going to take the same approach, 26 letters of alphabet, no repetition, right? Like what it is said. Repetitions are not allowed. So we are not going to repeat any letter once it's used. That's it. This is why in this case, when we say somebody is occupied here, we look at how many people are left, because we are not going to repeat that. And in terms of vacant posts, of course, there was nowhere where it can be 2 people occupying 1 vacant post. It will be 1 person at a post, just like that. So here, no repetitions, 5 letter words are formed as follows. We are simply getting 5. So we have 5 columns, 2, 4, 5. So we are saying the first letter that can be placed here, any of the 26 can be placed here. Once this is filled, how many letters are left? 25. So any of the 25 can be put here. Then once it's occupied, how many left? 24, and so on up to 22, right? So in a similar fashion, using the fundamental counting principle, 26 times 25 times 24 times 26 times 22, which is what we have here, right? So if I were to transform in a similar manner to continue on to multiply times 21 up to 1, then divide by the same thing, you'll find that at the end, we end up with 26 minus 5 factorial, which gives you that, which is the same as from 26 pick 5, which is 26 factorial over 26 minus 5, which is simply 21 factorial. Okay, so basically we are saying that's the rule for arranging subset of things. Repetitions are not allowed. Remember this. Now, let us look at the rule for arranging a subset of things. Repetitions are allowed in this case. So, number of arrangements of any things taken r at a time is given by n to the power of r. In this case, the repetitions are allowed. So I'm going to arrive at this rule through an example again, so that you can see that this is true. That as long as you have any things and you are going to have the subsets R, right? And repetitions are allowed, it's the same as n to the power of R, right? This example, how many 5-letter words can be formed using the letters of alphabet, right? Repetitions are allowed. Remember, we answered this question when repetitions were not allowed. So the answers that we are going to get are certainly different, right? So 26 letters of the alphabet, that is the value of n things, right? We want now to take an R at a time, that is 5-letter words, 5 spaces to fill, that is value of R, right? So for each space, you have to choose from 26. That means we have 5 spaces to fill, but for each space, you choose from 26 because repetitions are allowed, right? So here are the 5 letters, 1, 2, 3, 4, 5. But letter number 1, the 26, all of them, any one of them can occupy. Letter number 2, any of them can occupy. So this is all what it means without, repetitions are allowed. We are saying if the letter occupies here, it has a chance of occupying the second or whatever the case might be. But the thing is, at any point where we are saying the first letter, all the 26 have a chance of being there. The second letter, all the 26, because the repetition, the letter that could have been placed here, it has a chance of coming here again, even here until that. So as such, we are simply saying using the fundamental counting principle, 26 times 26 times 26, the 5 of them, right? So the shortcut of repeated, that is writing this in powers of 26, because that's the repeated number which we are multiplying with. So this is the same as 26 to the power of 5. So you have seen that we have n being 26 letters. The subset R, so n to the power of R, and you have seen that we have 26 to the power of 5. So n to the power of R. That is how you are supposed to apply the rule for arranging a subset of things. Repetition are allowed. Let's now look at the key takeaways from this presentation when it comes to the rules. The rules for arranging a subset of things. These 2 rules are there when we arrange subsets of things. That is what should be important to you. Then we are saying number of arrangement of anything taken R at a time, because already we are simply responding to the idea of arranging a subset of things. These are the things, the subset is R. So what do you do? Situation number A, repetitions are not allowed. How do you arrange these things? You pick from n things, R subset, it's the same as n factorial over n minus R factorial. Situation number B, repetitions are allowed, is simply n to the power of R. So this is all what matters. What you need to understand once you remember the rules for arranging a subset of things, right? When there's repetition, when there's no repetition, then these are the 2 respective formulas.